So for lesson 8, we are going to understand linear functions. So it says we have worked with functions who have a constant rate of change. And what that means is that the rate of change was the same between 2 points no matter where you were on that graph. So it was always changing by the same number. And the graphs of these functions have always been a straight line. So for an introduction here, the formula for perimeter of a square is perimeter equals 4 times the side length. And we have a table here that we're going to have to fill out. So if the side length is 0, the perimeter would be 4 times 0, which would be 0. And then if the side length was 1, we would have to do 4 times 1, so that would be 4. 4 times 2 would be 8, 4 times 3 would be 12, and 4 times 4 is 16. And then we are asked to graph that. So everything is positive, so I'm just going to put the first quadrant of graph here. Our first thing listed, remember, is our x's, and the second is our y. So we have to go up to 4 on our x-axis. And we have to go to 16 on our y. So I'm going to go by 2's. And our first point is 0, 0. And then over 1 up 4, over 2 up 8, over 3 up 12, and over 4 up 16. So as you can see, that forms a straight line. The table and the graph show that the rate of change is 4. So you can see that our rate of change for every one of our x's, every one over here, we're adding 4 over here. And then on the graph, you can do the rise over run. So up and then over. This is starting at 4 and we're going up to 8. So that's going up 4. This is starting at 1 here and going over to 2. So that's going over 1. So 4 over 1 is equal to 4. And that's the same thing between no matter what 2 points we pick. We're going up 4 and over 1. So in the equation, y equals mx, m is the rate of change. So that number in front of x is what our rate of change is, or our slope is. It's what it's called. And the x and the y are ordered pairs shown in the table and the graph. So our equation for this particular one would look like this. Just y equals 4x. Equations in the form of y equals mx create a straight line when graphed. If a graph of a function is a straight line, it's called a linear function. And it has line right in its name. Okay? Linear function is a function whose graph is a straight line. So for this next one, we're going to create a table and a graph for the function a equals s squared or y equals x squared. These two are similar. This one just simply means area equals side squared. And then the second one, we just replace the a with a y and the s with an x because we are used to using x for input and y for output. So, and then they want to know, is this going to be a linear function after we graph it? So y equals x squared. So basically we have to take every input and square it. So 0 squared, 0 times 0 is 0. 1 squared would be 1 times 1, so that's 1. 2 squared is 4. It's up here, I typed 2 twice. This should be a 3. 3 squared would be 9. So now I have to plot those points. 1, 2, 3. And I have to go up to 9. And our first point is 0, 0. Then we can go 1, 1, and over 2 up 4, and over 3 up 9. Oops. This is not a straight line. As you can see, it kind of has a curve to it. So is this a linear function? We can say no, it is not. It does not form a straight line. All right, complete the table and graph the ordered pairs. Is this a linear function? So this one they're telling us we have to do x squared and then add 2 to it. So for the first one, we're going to do -2 squared plus 2. So -2 squared would be 4, and 4 plus 2 is 6. And then -1 squared plus 2. -1 squared is -1 times -1, so that's 1. Plus 2 would be 3. And then 0 squared plus 2, that would be 2. 1 squared plus 2 would be 3. And 2 squared plus 2, that'd be 4 plus 2, which would be 6. So now we're going to have to graph these. Our first ordered pair is -2, 6. Then we have -1, 3, 0, 2, 1, +3, and 2, +6. So this is kind of a U shape here. And it says, is this a linear function? No, this is not a straight line. This is a U shape. It's called a parabola, and we'll get into that later on in algebra. All right, for this one, we're going to use the equation 2x plus 1 equals our y to complete this table. So for the first one, we're going to have to do 2 times -2, which would be -4. -4 plus 1 would be -3. And then we're going to do 2 times -1 plus 1. So that would be -2 plus 1, which would be -1. 2 times 0 is 0, plus 1 would be 1. 2 times 1 plus 1 would be 3. And 2 times 2 plus 1 would be 5. So -2, -3, -1, -1, over 0 up 1, over 1 up 3, and over 2 up 5. So yes, this is a straight line. So this is a linear function. All right, and then last, we're going to take a look at these graphs here, or these equations. Or for each function, the first thing that we have to look for is its initial value. So if you remember, we're looking in the form of y equals mx plus b, and m is the rate of change, and b is our initial value. So for the first one, we're looking for initial value on everything. And y equals 4x does not have a plus or minus at the end, so we can just assume it's a 0. So its initial value is 0. Same thing here. We don't have a plus or minus on y equals x squared, so that would be 0. And then y equals x squared plus 2 has a plus 2, so that would be 2. This one would be 1, and this one would be 0. The rate of change is that number being multiplied by the x. So the first one is a 4. The next one is something that we can't determine by this equation because it's not in mx plus b form. It's got a squared there, so it can be anything right now, so we're not sure. Same thing with the next one. It's got an x squared, so it could change. And then this one, 2x plus 1, there's a 2 in front of the x, so we can say 2 because it's just a regular x. And then y equals x to the third power. Again, it's not just an x, so it could be any number. We're not sure just by looking at our thing here. And also, it means it's not a straight line. So which part of the graph are they talking about? Where do we want that rate of change? It doesn't have the same all throughout the graph. So those 3 that we didn't write anything in, that's because the rate of change between different sets of points is different. So we can't just say it's always going to be a certain number. That's not the case with those. All right, and then the equation form, what does it look like in terms of mx? So this one, y equals 4x, looks just like y equals mx. There's no plus b at the end. This y equals x squared would be something along the lines of y equals mx squared, which is not what we're learning about in linear functions. And this one would be y equals mx squared plus b. So that's definitely not linear form. It doesn't match up with what I wrote up here at the top. And then here we have y equals a number times x and then plus a number at the end. So that's an mx plus b. And then this one, mx to the third power. So for our last thing, does it look like it's in this form? This form creates a straight line. And like I said at the very beginning, that first equation, we can assume it's plus 0 at the end. So yes, if we add that plus 0 on, it looks just like mx plus b. So we can say, yes, this is linear. I guess I shouldn't say yes, I should say linear. This one, mx squared, does not match mx plus b, so this is nonlinear. Again, same thing here. We have an x squared, does not match mx plus b, so that's nonlinear. This is mx plus b, so it's the exact same thing, so that would be linear. And then mx to the third power has that exponent of 3. Mx plus b does not have an exponent of 3, so this is nonlinear as well.